Okay, now we're going to look at vertical and horizontal shifts of parent functions. Vertical translations, also known as shifts, okay, are the sliding of a toolbox function either up or down, okay? Using function notation, if f of x is our parent function and some g of x equals f of x plus some k value, then the graph of g of x, or the graph that we're looking for, is just the graph of our parent function shifted up k units. Okay? If we have some function g of x and we know it's our parent function just minus some value k, then g of x is the graph of f of x shifted down k units. Okay, so let's take a look at this. This box up here is important to make sure that you understand. But examine the chart below for the function g of x equals x squared plus 2. We'll do that one in red here. And its parent function. Now, what is its parent function? Well, notice again that we have an x squared here. So the parent function is x squared. So what I've done here is I made a chart for us already. We don't have to compute it. And x squared is here, and our x squared plus 2 is right next to it. Now, we can graph that quickly here. If we look, I always start at 0. It just kind of helps me. But at -1 we have 3. At +1 we have 3. Okay, and at -2 and +2 we have 6, which goes off our graph over here. What you'll notice, if you look at it here, that each one of the values, and this should make sense, from x squared to x squared plus 2 is just 2 added to the parent function, which shifts the entire graph up 2 units. Okay? And so anytime you take a function and you add or subtract from it, you can really just think that you're adding or subtracting from the y values of the parent function. It's important to see that they are, the function and y values are synonymous. Horizontal translations, on the other hand, are the sliding of the toolbox function right or left. Okay? Now this one's, you have to have a good handle on function notation to understand this. If you're given a g of x, and that g of x happens to be f of x minus some h value, then g of x is the graph of f of x shifted h units right. Okay? Sometimes people have a hard time dealing with this because it's x minus h, and it shifts it to the right. That's how it shifts it. We'll look at that here in a second. If g of x equals f of x plus h, then g of x is the graph of f of x shifted h units left. Okay? So let's take another look at this example here. Examine the chart below for the functions g of x. In this case, g of x equals x minus 1, the quantity squared. It's a little bit different than what we had last time. And its parent function, again, because we have this squared right here, would be x squared. Okay? Let's compare the y values again at the same x values of each on each graph. Okay, so what I've done again here, the first column is just x. Our second column is what x squared would be, and our third column in red here will be x minus 1 quantity squared. Okay, now what you have to understand here is if we plot this, and let's just start here at 0. So at 0 we have 1. At 1, we have 0. At 2, we have 1. I'll go back to -1 here. We have 4. So at -1, we're up here at 4. And if you look, we kind of run off our graph here, but if you look, what you can see is the red graph, which is g of x, which is represented by x minus 1 quantity squared, is just shifted over 1 unit to the right. Okay, 1 unit. That's because of this -1 here, and you'll notice that's consistent with what we have up top. If we have x minus h, then it's shifted h units to the right. Okay? And you'll notice that your y values are all shifted 1 unit to the right of the x values of the parent function. And just to verify this, we'll take a look at it quickly here. Here again is my parent function. I'm just going to copy the input here, and you watch if I put in the quantity x minus 1 squared, and I hit enter, you'll notice that it shifted it over 1 unit. Okay? We can see that occurring here. Okay? So that's what we just observed.